Today I'm going to talk about this LeetCode question, graph valid tree. So given n nodes labeled from 0 to n minus 1 and a list of undirected edges, where each edge is a pair of nodes, write a function to check whether these edges make up a valid tree. You can assume that no duplicate edges will appear in edges since all edges are undirected. 0, 1 is the same as 1, 0, and thus will not appear together in edges. Okay, so basically you want to check if these list of edges create a valid tree. So let's just draw this first example out first. So I have 0 and then 1 and then 0 to 1, and then of course 1 goes back to 0, and then 0 to 2, and then 0 to 3, and 1 to 4. Is this a valid tree? Yes, it is. So what about this example? What makes it an invalid tree? So we have 0, 1, 1, 2, 2, 3, 1, 3, okay, and then 1, 4. So this is not a valid tree, and this is because there's a loop here. Okay, there's a cycle going on, so that's not a valid tree. What's another case where something isn't a valid tree? Well, if the question says you need to check if all these edges make up a valid tree. So if you have like a separate edge here, like 5, 6, of course this still doesn't make a valid tree. This doesn't make a valid tree anymore because we have this group here and group here. They're disjointed. They're not connected like this. So that doesn't make it a valid tree. Okay, so there are two criteria to a valid tree. No cycles, and 2, all nodes present in tree. Okay, so how we're going to do this is starting from 0. We're gonna basically traverse the tree using a depth first search and check if there's no cycles, and then if after we do that first search, check if all nodes are present in the tree. Okay, and how we're gonna check number 2? Well, we're gonna keep a visited set. I drew it as an array here, but it's gonna be a set. Okay, and every node we visit in this list of edges here, we're going to add it to our visited. And of course, if all the nodes, connected from 0 and traveling down are in visited, then this is a valid tree. Along with that, if there's no cycles. Okay, so if we run through DFS, how it's going to look is, so for this first one, we have visited. Okay, so how it's going to look is first we're going to go to 0, okay, 0, and then with 0 we're going to go to 1, okay, 1, and then from 1 we can go to 4 or go to 0, okay. This is an these are undirected edges, okay, they have no direction, so we can go backwards or forwards. We don't want to go backwards here, okay, or else we'll get a false positive for a loop detection, okay. So how we're going to mitigate that is in our DFS call. Where we're not only are we passing like the node we're going to visit now, but also its parent. So that when we look at the node's children, and by the way, we're going to store these in an adjacency list. So when we visit the node's children, if one of his children happens to be his parent, we don't visit that parent, okay? We just move on to other children. So that's how we're going to do that. So yeah, first I'll map out the DFS calls here. So first it's going to be when we map 0, when we visit 0, at first it's going to be 0, -1. Why -1? Because it has no parent, and we know we have n nodes labeled from 0 to n-1, so -1 will not be a parent. So we just have it as that, okay? And then we visit 1, and then 0 as its parent, and then we visit one's children, excluding its parent. So then 4, 4, 1, okay. Great, we're done with that call there. And then go back to 0. We visit the rest of 0's children. Okay, 2, 2, 0, and then 3, 0. Okay. And we know this is a valid tree because all the nodes are unvisited and we do not detect any cycles. Great. What about this guy here? What does its visited look like and its DFS calls? Okay, so visit, so we're going to start from 0, okay, 0, and its DFS calls will be 0 minus 1, okay, and then 1, and 1, 0 is parent, okay, visit is 1, and then 2, okay, 2, 1, great, visited 2, okay, 3, I call 3, 2 here, okay, visit these 3 children, and it turns out 3 children, that's not its parent, is 1, but we already visited 1 here, so therefore we just detected a cycle, and this is not a valid tree. The time complexity of this is O of V plus E, because we're visiting each edge at most once and each node at most once. Okay, now to code this up. So first thing I want to do is create my adjacency list, which is going to be a dictionary. So with my adjacency list here, what I'm going to do is iterate through the nodes. So for I in range n, I'm going to initialize my adjacency list for all nodes n to initially be just an empty array. And now I'm going to iterate through edges. So for I in edges, I'm going to populate the array, this array in adjacency list with all the appropriate children or edges. So adjacency list I 0 at this edge and okay, and same with the other way around. Whatever that the first position in this edge here, add this as a child because this is an undirected graph. Okay, great. And then what I want to do is define my depth first search function and then parent. And what it's going to be the base case here. Before that, I'm going to define my visited set. Okay, and then here, my base case would be if node in visited false. Okay. Otherwise, what I want to do is add node to visited. Okay. Add node to visited, and then get all the children per node from my adjacency list. Okay, and then what I want to do now is iterate through each child in children. So for child in children, if DFS child and node, remember node is going to be its parent of each child. It goes false, turn false, And after all that, we recursively visited all the children. If this we never reached a false statement, we're going to return true. Okay, so that's pretty much it for this. And then after that, what I want to do is if DFS start 0 minus 1 equals true, and length of visited is equal to n, return true, otherwise return false. Okay, try running my test here. Oh, we're spelling error. Let's see, node, get the children, reach child and children. Oh, I forgot. If child is equal to parent, then continue. Okay, we don't want to visit its parent and get a false positive for a loop. Just gonna separate the code out here. Key error 0, that means, oh shoot. Should read the error message key error. That usually means an element doesn't exist in the dictionary that we're trying to access. There we go. And submit. And great, thanks for watching.